Hey guys, today we are going to talk about the engineering design process. So your notes will say engineering design process on the top, and then on the back there's also the different steps that we are going to walk through in this video. So the engineering design process is used by engineers to create new technology and make improvements to our everyday life. So every time you get an app upgrade, every time a new phone comes out, even when you see some cool new design for a mechanical pencil, that is all gone through the engineering design process. So I want you to watch this video with me. It's only going to take a few minutes, and take just a couple notes down on what you think an engineer is or does, or why they're important. Did it again. There we go.
You find things made by engineers everywhere. You look around, everything you see, your car, your toaster, your shoes, your house, the building you go to school in, there was a civil engineer involved in that. The computers that we play on, there was a mechanical engineer, an electrical engineer, paints, you name it, anything, toilet paper, shampoo, food products, engineering is all around you. Engineers are everywhere.
I think it would take somebody with a really powerful growth mindset to accomplish things like this.
Because, you can't just think about it. You have to actually think about it, because those things are really hard to think about.
You would need to have problem-solving skills.
It's just a matter of having a little curiosity and the drive to do something to help the world. I think sometimes we can be stereotyped as you have to be nerdy, or you have to be a boy, or you have to look a certain way, and I don't think that's true. I think anyone can be an engineer. A good engineer is able to come up with creative solutions to problems. They communicate with a lot of people of different fields and just working in teams.
You have to have the thirst for knowledge. You have to always want to learn.
Anything science related, so biology, chemistry, calculus, physics.
You absolutely do not have to be a math whiz to study engineering.
I think you have to be able to understand basic concepts of it, but I don't think you have to be some genius to be an engineer. Engineers will always be in demand. That's one of the reasons why I chose engineering, because you will always need engineers to help you solve the next generation's problems.
Engineering gives you so many opportunities. There's so many different disciplines you can get into.
I can't think of another profession that has the flexibility that engineers have and the type of work that they can do on a day-to-day basis and on a career-long basis, different areas that you can get involved with.
It's incredible to think about what we can do as engineers to impact the world.
Okay, so from that video, that's just a really good introduction to what engineers are. We're going to be doing several engineering projects throughout the year because I went to school for engineering, so I'm pretty passionate about it. And we do need to learn about the engineering design process anyway, so it fits together pretty well. So the engineering design process are just a series of steps and guides that gives engineering teams a way to solve problems. And it's iterative, which means that we repeat it over and over again. So just because we came out with a phone that worked doesn't mean we stopped at a corded phone. It means we keep going and trying to get better and better. And now you have, iPhone 800 or whatever we're at right now. And the big idea from engineering and from most science altogether, is to learn from failure. If you don't learn from your failures, then you can never improve. So just because, remember that Samsung Galaxy phone where the batteries like blew up? If they would have just stopped there, where would we be now? So we have to learn from that. We have to improve on that, and we're always making things better and better. So here is your kind of cycle wheel here on the front. The arrow didn't copy very well. Just know that all those boxes go in a circle. So these are all your steps of the engineering design process that we're going to talk about here in a second. We identify, we research, we imagine, we plan, create, test, and then improve. I think I ran out of fingers somewhere in there. So write this down on the front of your sheet, and then we're going to go through each of the steps on the back of the paper. So the first step, this is going to go on the back of your paper, and we'll fill in the wheel here in a second. The first step is going to be identify. So we have to identify a need. You have to come up with something that needs to be better or needs to be improved so that we can engineer it and build it. And there's nothing too crazy to try to make better or something that you think could exist in the world. Elon Musk is probably known as one of the craziest people in the world, but all he is doing is sitting there and thinking of things that no one else has the courage to think can exist, and he's making it happen. Then we have to brainstorm our constraints. So let's say that you want to build a flying car that runs on gerbils running around wheels. Not too crazy. What if we end up with a huge gerbil population and we have to do something to help control it, but also use up their energy somehow? So we need to come up with, why can't these things exist now? What's holding us back? Or what are the limitations that we have within our own area? So within our classroom, we only have certain materials, we only have certain amounts of time. Maybe there's a size constraint, maybe there's a cost constraint. There's always going to be something that kind of limits it right now, but remember, we're always going to be improving it later on. And so we want to know what those limitations are and why it doesn't currently exist. And if you've ever watched Shark Tank, there are people that sit there and they'll come on and say, I just couldn't believe that this didn't exist somewhere. And so if it can, why not make it? So we identify that need. Then step 2, so again, we're moving down this back page with all the steps listed, is to do some research. So you would want people to use your item, and you're trying to improve people's lives. So we tend to poll people, we do research online to see what's already out there, and we ask questions. So what things already exist? What things can we improve upon that someone has already created the basis for? What do people actually need, or what do they want to improve their lives? And what do people think can be improved of our current prototypes? In step 3, we just have to imagine. So you're going to sit there and think of every possible way we can solve the problem. Again, nothing is too big, nothing is too crazy. We'll work on bringing it down later, but you can't think of your limitations. You are literally just going to go from your imagination, what could be. Then you have to have a plan. So once you've come up with all these crazy ideas, you're going to start narrowing them down based on what your limitations are and what your top priorities are. Sometimes you can't do everything at once, so we have to do piece by piece and come out with a new thing in each iteration, which is what you see a lot with phones now. So they might be able to do all these amazing things, but it might take 10, 15 years, and they can't do that in the market they're in. So they're only going to do one major step at each phone cycle. And then your plan needs to include product sketches and descriptions of how pieces are going to work once it's built. So you're going to draw out or sketch out on a computer kind of a rough idea of a top view, side view, and front view. And when we get into our first design, I will show you more about that. But also you want to write out how you think it's all going to work together, because once you draw a picture and once you start seeing how you think everything is going to interact, it actually helps you really focus in on what you're going to try to build. So the next step is to create. You're going to actually build a prototype from your sketches, and you want to track things as you're building that you hope to improve on. So that might be a cost or size, or maybe there's got to be a simpler way to attach a piece here, or maybe you did some steps in reverse and you need to really flip-flop them the next time. You're going to track all of those so that when you go through the next iteration, you already have an idea of what can be improved. Then the fun part is testing it. So you're going to, test that your prototype is actually capable of improving life. So it's actually fulfilling some of the needs that you were trying to solve in the first place. And you want to track things of what went well, what went wrong, and what could be better. So if you maybe built a new type of shoe, maybe what went really well is it fit people really well. It really conformed to their foot. What went wrong? Maybe it broke apart really easily because the fabric you used was way too soft. And so what could be better? Maybe we could build stronger seams in. So we're just kind of tracking those things as we test it, and you want to test it with multiple people. Then you improve. So we're going to restart the entire cycle and improve on your previous design. Everything can always be better than what we currently have. And so you want to make sure you're not thinking of anything as a failure. You're thinking of it as a stepping stone to another improvement.